In this video, we're going to be talking about constant motion. So this constant motion, we're first going to be looking at a distance versus time graph. So on these distance versus time graphs, you're always going to see distance on this y-axis, and you're always going to see time on the x-axis. So remember back when we talked about independent and dependent variables, time is going to be your independent variable because technically you are changing the amount of time that you're allowing to pass. You're manipulating time. Distance would then be your dependent variable. So it's going to be your dependent variable because distance is what you're measuring. You're measuring how far the object traveled and however much time you allowed it to travel. So let's look at a scenario. So you roll a ball along a table and it's illuminated by a strobe light every second. So you're mapping out for at 0 seconds, it starts at 0. At 1 second, it's here at the 1 centimeter mark. At 2 seconds, it's at 2 centimeters. 3 seconds, 3 centimeters. Okay, so you see the pattern, right? For every second, it travels 1 centimeter. So it continues moving at the same speed the entire time. You can even put it in a table. So you have distance in centimeters and time in seconds, and you can map it out. So because you have this data, you can also plug it into a graph. So for each point, you'll just plug it into your graph. So for the first coordinate point at distance 0 times 0, it would go here. At a time of 1 second, it traveled a distance of 1 centimeter, and so on. So you can graph out your entire motion, and you can even draw a line through it. So as you can see, the motion doesn't change. It has this straight line. So on these distance versus time graphs, so far, we've seen these straight lines being included on the graph. So this one even has an upward positive slope. So what kind of motion created this graph? Well, when we talked about that ball rolling across the table, the motion didn't change. It was a constant motion or a constant speed. So the ball speed did not change. So the first graphs that we're going to be looking at for these distance versus time graphs, we're going to be looking at 0 speed, so an object at rest, and then we're going to be looking at constant speed. So maybe it's a positive or a negative constant speed. Constant speed is represented by a straight segment on a distance versus time graph. So straight segment meaning if you have distance on the y, time on the x-axis, some sort of straight line. We're only going to be dealing with straight lines, all straight lines. So for this first scenario, you said that the object starts in the negative position of the graph. So maybe it starts 10 meters to the left, because this is the negative portion of the graph, this is the positive portion of the graph. So this object starts 10 meters away and it goes to 5 meters away, 0 meters, it's right at the origin here, and then it continues moving past the origin to the right. However, it's a straight line, so it's a constant speed and it's moving in the positive direction. So it has a positive slope, this line does, so the object is moving in the positive direction. So this could be for example, the object moves at a constant velocity of 2 meters per second to the right or north. So because it's that positive direction, you would use right or north. All right, on the other hand, you're going to have a negative slope. So as you can see, you start in the positive position on the graph. Maybe you're 10 meters to the right. Then you start moving backwards towards the origin. So you're moving towards the left to go back towards the origin. Then you pass that origin and you continue walking more to the left. So this is what a constant speed in the negative direction looks like. Negative direction because the object's moving maybe to the left or south. It has some sort of constant velocity, so maybe again it's 2 meters per second, but this time it's to the left or south because it has this negative slope. All right, and our final piece to the distance time graph puzzle. So another straight line, however, now it's a horizontal line. So this horizontal segment means that the object is at rest. The object is at rest, maybe it's 5 meters to the right of the origin. So remember, this is our positive part of the graph and this is our negative part of the graph. Positive could mean right and positive could mean north. So as you can see, the object is somewhere on the positive part of the graph, Maybe it is 3 meters to the right or 5 meters to the right. It's some sort of meters to the right of the origin. All right, when we look at these distance versus time graphs, you can calculate the slope of these graphs if you have 2 points. So remember, we do know how to find slope. Slope is the change in your y values divided by your change in your x values. Or remember, you can do rise over run. So if you're going to do rise over run, you start with your leftmost point and you would rise up 20. So you go from 10 to 30, the difference is 20. Divided by, well, your run, you go from 0 for your time to 30 to your time, so 30 seconds. So that's going to give you 0.67, or 2/3 essentially. Okay, or you can use the coordinate points. You can plug in your values, so your y1 and y2 values. So remember, change in y is y2 minus y1 over your x2 minus x1. So you can plug in your values, simplify, and you get the exact same answer. So no matter how you want to solve for the slope, both methods are perfectly fine. So when you solve for the slope, notice that your change in y values. So your change in y values is position. So you essentially have position on top divided by, well, you're changing your x values as time. So if we're talking position over time, you're solving for speed or for velocity. So anytime you find the slope of a line on a distance versus time graph, you're essentially solving for the speed. So this slope that we calculated, the 0.67 meters per second, that's the speed of this object that we've graphed. All right, let's look at an example. So sometimes in physics class, you'll have graphs and you'll have to interpret the motion or maybe match the type of motion. So let's start with this first segment of the graph, this pink line. You can see that the object starts at the origin and it moves 60 meters away. And it's 60 meters to the right of the origin because these are positive values and down here are the negative values. So remember, positive values could mean to the right or north. All right, let's look at the next segment. So this green line, remember it's a horizontal line. As you can see, the object stays right at 60. So that means it stays at 60, 60, 60. So the object is not moving. It's staying at that 60 meter mark. Our next segment, I'm going to break this up to just look at this purple part of the segment. So as you can see, the object travels from the 60 meter mark back down to the origin. So it's having to go backwards. So that means that the object moves 60 meters to the left to go back to the origin. All right, at this point, at the 30-second mark, the object is at the origin. However, you can see in the next segment, this red line, that the object moves past the origin. So the object continues moving to the left. And it even goes 40 meters to the left past the origin. All right, in our last segment, this blue line, you can see that the object travels from the -40 mark, so the -40 mark, all the way back to the origin. And because it has a positive slope and it's moving back towards the origin, it's moving towards the right. So you'll notice in these scenarios that for these distance versus time graphs, if you have a slope that is positive, so this is your positive slope, this is your positive slope. Notice how whenever you have these positive slopes, the object is moving to the right. And then the opposite for your negative slopes. So for these negative slopes, you have here is a negative slope, here is a negative slope. The object was moving to the left. And then, of course, with this flat line that you have where the object is not moving, anytime you see a horizontal line, it could be, the horizontal line could be here, it could be down here, it could be down here. If it's a horizontal line, the object's not moving. All right, so let's summarize. So if we have a horizontal line, that's going to be no movement. A positive slope, the straight line, is a constant speed to the right, or we said it could be north. A negative slope with that straight line is going to have a constant speed to the left. So on a graph, a horizontal line could be no movement, so maybe it's a horizontal line there. Or it could be a horizontal line here, or it could be a horizontal line here. So again, the horizontal line could be anywhere, and that just means that there is no movement. A positive slope. That purple line represents the positive slope. The object's moving at a constant speed to the right. So maybe it's 2 meters per second to the right. And our green line represents that negative slope. So the negative slope is going to represent a constant speed to the left. So it's constant because all these lines are straight lines. There is no curvature to these lines. So this green line has a negative slope. That means it's moving to the left. And it's a constant speed because it's that straight line. So maybe it's -3 meters per second. Or you could also say 3 meters per second to the left. Either is fine. All right, thanks for watching. If you have any questions, leave